Hi Vijay.
Hi Hemanth, welcome to this webinar and good afternoon everyone who are here with us today. We'll be starting in about a minute's time. People are just streaming in, so we'll start sharp at 3 o'clock. All right, good afternoon everyone and welcome to this Face Pulse webinar series. My name is Vijay Anand. I'm going to be the host today. And we have with us Hemanth from Amazon, who has graced the occasion as a panelist. Welcome Hemanth and thanks for taking the time out.
Thanks Vijay. Thanks for having me here.
And we also have Venkat with us. He'll be joining us in a minute. Venkat is the co-founder of Face and he'll also be part of the panel discussion. So before we start, I thought I'll give a quick introductory context to what we do so that this rest of the session can begin. So if you're new to this, we've been doing some online sessions for faculties and TPOs and college management over the last couple of months since the Corona lockdown. So you can find all of these recordings on FacePulse YouTube channel, which is youtube.com/FacePulse. We've been doing two kinds of sessions. One is faculty development series, and another is transformation essential series. So this is the second episode of our faculty development series. You can check out what happened in the first episode on our YouTube channel. So the topic for today is new paradigms in teaching code. So while I start, I'll first give a quick introductory context. So there are many existing paradigms in teaching code. So before I pass on to the panelists to discuss what the new paradigms and perspectives would be, I thought I would set some context of what the existing paradigms are when we named this particular session. So having interacted with students across the country from engineering campuses and also trained them to secure their first graduate jobs, one of the main things that we often come across is that coding and programming skills are essentially for just the CS and IT students, and hence we may not need to worry about acquiring those skills. While to an extent this might be true, the world is fast moving to a stage where everything is run by technology, and tech literacy is demanded of any graduate, a civil engineering graduate, a chemical engineering graduate, a mechanical engineering graduate, everyone to operate machinery, operate equipment, operate or set design any products within their industry, they will need to have a very high degree of technical literacy. And one of the best ways to get them tech literate is to teach code. Even if they do not end up becoming programmers, they need to be sufficiently equipped to be able to handle all the technical components and interfaces of the machinery or equipment they operate, so that they understand how machines work through a coding interface. Some of them may not need to draft any code themselves, but some of them will even be interested and actually pick that skill up. So that is the first context. The context is teaching code is for everyone in this 21st century. The second existing paradigm that we often come across is that we are still teaching C++ Java. There's nothing wrong about it, right? So when I finished my graduation in engineering, I learned C++ and Java. But the problem is we are still teaching them C++ and Java in a more console-based manner, at least for the entry-level first-year grads. Many universities, many colleges, I don't want to generalize here, but I have personally seen that students are picking up coding in a very console-based mode. While the world still, majority of the tech platforms run on C++ Java, the applications they actually push and actually make run are completely different. Today we are seeing mobile apps, we are seeing SaaS platforms, the applications that were there a long time ago in the early 2000s, which C++ and Java used to run. These applications are completely different now. So that transition has not quite happened when students are introduced to coding. So ideally in my world, if I were to teach someone coding right now, I would teach them to design a simple website and actually make it live. It could even be a simple blog. So that kind of what you see is what you get approach is still lacking in some places. So that is part of the existing paradigm, which might be making us constrained in how we might approach this. The third thing that we wanted to touch upon as an existing paradigm is there's a lot of theory-based teaching in silos. Theory is absolutely important, no doubt about it, but it is happening in silos. For example, I might teach someone the fundamentals of database management extensively and rate that student's performance through assessment and examinations. And then in the next semester, this person learns front-end design. Front-end design is actually completely rated, evaluated in assessments and examinations. But then when the student graduates, this student, most of the students that graduate after these two sessions never actually connect the two, front-end database and back-end. Only in the final semester when they have to do a project do they think of even connecting all of these learnings. But if you notice, the teachers and the faculty that are responsible for teaching them these individual silos have done a good job. But currently in the system, there is no one who's going to tell them how to stitch it all together. Some students form hackathon clubs, etc., and do it themselves, and they seem to excel in placements. But if we can come up with a system where this is done actively institutionally, I think we believe that silo-based model can transition to a very practice-based approach to actually getting students to code, seeing things actually work in practice in an experiential way. The last point that I wanted to touch upon in an existing paradigm that we see as problematic is lack of exposure to real world scenarios and exposure. The students often come up, if second year student, for example, comes up with a brilliant idea for an app. And we ask a simple question: can you use some of these approaches in improving the current Uber app, which is a cab aggregator, or a Swiggy app, which is a food delivery service provider? Mind you, these students use these two apps fairly regularly. Now they are not able to think business context outside of what they might have come up with and solve a problem. How would you improve a Swiggy app? I'm not able to see Swiggy as a potential real life experiment that I could probably play with. I'm not able to see Uber or Ola as a potential real world project that I could play with and try to improve. I don't see it that way. So I keep my academic world aside and I keep my, all the technology that I interact with on a daily world aside, which means I'm never bringing these two scenarios together. And if someone can help them see that, we would be making great programmers every day. The second part of this fourth point, which is lack of real world exposure. So last week we had an interesting webinar on internships, fostering internships among students, and we were discussing that internship could be potentially a pathway to full-time employment, and students should start doing internships. More than just that, internships actually seek to provide very wonderfully the real world exposure that we want them to get as coders and programmers. So if real world exposure like an internship can actually help the student from first year to third year, even into the final year, we believe they would be not only setting themselves up for employment, they would actually be becoming better programmers. So we believe these are some areas where institutions can actually come up with innovative models to solve these problems. I'm not saying all of you who are attending, all the HODs and deans and principals who are attending, you may not have thought about this. We are just sharing this in a broader context so that some institutions who may have these issues can potentially think about how to solution around this. Now, with this context, I would like to quickly introduce the panelists and hand over to them. So the first panelist we have with us today is Hemanth Kumar. Hemanth is a software development engineer too at Amazon.com. He's a former assistant professor at Department of Computer Science Engineering at PSG College of Engineering and Technology, Coimbatore. He has also worked as a software engineer in Cisco before embarking on his academic stint. He's an alumnus of College of Engineering, Anna University, Guindy, and National Institute of Technology, Trichy. A small correction there. He is a former assistant professor of PhD College of Technology. I apologize for the typo there. So Hemanth has worked in both academia and corporate world, and we believe his insights will be very, very valuable today. Welcome, Hemanth. The next panelist we have with us today is Venkata Raghulan. Venkat is the co-founder of FACE. He's also the program leader of FACE Prep's ProGrad programs in technology. So he's been focusing more on technology learning in our business. He's an alumnus of College of Engineering, Anna University, Guindy, and also of the Indian Institute of Management in Kozhikode. Prior to starting up FACE, he has worked in organizations such as Deloitte Consulting and Citibank. He's passionate about technology, and he actually frequently participates in top coding bootcamps in the world to explore best practices in teaching programming skills. So with that a segue, I would like to transition to Venkat and hopefully ask him to share some of the practices and perspectives that he has been finding successful in running some of these programs, and maybe initiate the discussion with Hemanth. Thank you once again for joining us. Over to you, Venkat. I'm making you the presenter. You're live, Venkat. Yeah. Venkat, we can't hear you. We can't hear you, Venkat. Can you try now?
Can you hear me now?
Yeah, it's good. Yeah.
Yeah. Thank you so much, Vijay, and good afternoon, one and all. Right. Thank you for joining this webinar on new paradigms in teaching coding. Basically, like Vijay had already pointed out, I have been running these programs. I've been experimenting with how to teach coding for the last 4-5 years, and I've also been visiting these institutions, right, both on the formal education side, right, the world-class universities, as well as the informal education, right, where these boot camps are conducted, right, across the globe, right, primarily from the industry's perspective. And I'm going to share some of the perspectives and practices, right, which we have learned over the period of last 4-5 years, and which we think could make some difference to the way coding is taught. And like Vijay had rightly pointed out, that there are constraints, a lot of constraints, right, operating in a regulatory environment, especially for formal education pioneers. But having said that, there are certain things that if you can implement it along with the regulation, right, I think it will go a long way towards building some positive habits, right, and making coding effective, or teaching coding effective is the thought process with which I would like to straight away talk about one single biggest big picture insight, right, which we have realized, right, in the last 5-6 years in terms of teaching coding for almost lakhs of students, right? So the most of the methodologies, right, when it comes to teaching coding, they either adopt a top-down teaching methodology or a bottom-up teaching methodology, right? So what do I mean by top-down and bottom-up? Top-down is where people talk about something which is very, very big, and then try to break it down into high-level, smaller pieces, which also makes it slightly abstract, right? For example, I'm talking about distributed computing, right? So which is already an abstract topic, right? And I talk about why distributed computing is important, and then I kind of break it down into 4 other complex terms. The student really struggles to follow it in some cases. The bottom-up teaching methodology is also followed in a lot of subjects, and typically it is meant to be very effective. So what is bottom-up teaching methodology? For example, I believe these days we introduce Python or C programming in the first or second semester, where we talk about data types and variables and all the other stuff, right? The loops, conditional statements and stuff, right? And the student spends exorbitantly high amount of time in terms of learning each of these things, right? And practicing it, right? Which is a bottom-up teaching methodology, which is a typical way in which we learn any new language as well. Right? So when we talk about learning English or even mathematics when we started. So we kind of spend a lot of time in terms of the foundations, right? And that it has its both of the teaching methodologies have their own pros and cons, right? While the top-down thing tends to give the big picture, right? It also makes it too abstract for the student to grasp in the initial stages and discourages the student. Whereas bottom-up teaching methodology gives a lot of time for the student, right? Where he can practice, etc., etc. But the context is missing. The student, for quite a long time, does not really know why he is doing what he is doing, right? So we call it the depth and breadth conundrum, right? So do I go deep or do I go wide, right? So that and both of it has its own pros and cons. So what we follow, right, or what we have adopted, right, it is inspired from one of the professors in MIT, right, a machine learning professor in MIT. So he propagates something called as the whole game methodology. So what is this whole game methodology? He talks about giving the, so if I have to teach a kid football, it is important that I show him a game of football, and then I keep showing him a game of the same game of football in every step, right? For example, I show him the football and teach him what it is. Teach him the rules of football. I teach him one particular thing, dribbling, for example, or blocking. But in each step, I still keep showing him the entire game of football, and then try to teach whatever I am teaching in the context of the game of football, right? So that is something which is very relevant when it comes to teaching coding, is what we believe, because today computer science is perceived as an engineering discipline, and hence it is fitted along with let's say mechanical engineering or an electrical electronics engineering and stuff, right? But one single biggest advantage for computer science engineering is the gap between what is in the research and what is practically being used is the lowest when it comes to computer science, right? Whereas let's say I'm trying to come up with a new engine, right? So it is going to the research and development and the actual implementation of the research, right? There is going to be a huge time gap, right? So whatever is in R&D today will come hit the market only after 20 years or 15 years, right? In traditional engineering disciplines, whereas computer science, the gap is quite narrow, right? So whatever we is in R&D today might hit the market tomorrow, right? So that is the reason why it is important to not look at computer science only with bottom-up teaching methodology, right, or top-down, right? It should be something which is a blended model where we constantly keep telling the student, hey, this is the whole game, and this is why you are learning what you are learning, and that is the big picture insight, right, which we have in terms of operating these or delivering these boot camps, right, for students. And this is the insight which I've also kind of garnered from visiting a lot of these boot camps across the world, as well as the formal education institutions abroad, right, are trying to adopt some similar methodologies in order to connect with the student, right? So ensure that depth is met, right, in case of learning the basics of programming, or even in things like algorithms and data structures, right? The student has to learn it very deep. At the same time, width is also needed in certain things, like, for example, any front-end frameworks or Angular and React frameworks. So in any of these things, right, it is important that the student knows the big picture, but he has to keep moving on and he has to start implementing things, right, with whatever he knows, rather than trying to kind of learn it in and out, because the idea is the technologies keep changing, and it is never enough, right, that the student learns it in before he learns it in and out, the technology would have already moved on, right? So the foundation concept should be bottom up, and any advanced concept which is built on foundation should be top down, and the whole thing should be taught from a whole game perspective, is the big picture learnings which I have got, right? Naturally, what is right or what is the best way of teaching is something which we might not know, or I might not be the appropriate person. But what works is something what works with the Indian students, and what is also being broadly pursued in the global scale is what I have tried to kind of touch upon. And so this is the big picture. And then I also would like to talk about some of the best practices quickly, right? So I would not like to take a lot of time here. I will quickly glance through these things, primarily because we have Hemanth, who's a who has had a very interesting career, right? So he has been in the industry. He has been with Cisco and Amazon, and then he has been in academia, right? So he has been a assistant professor in PhD Tech as in the formal education system, and he is currently in the industry. So I'm sure he'll be able to bring in completely different perspectives from both sides of the table. But I am purely going to give some best practices which I have adopted from the informal education standpoint. Right? Given that we have been doing that, pioneering that for quite some time, for a decade now. So the best practices which we have seen work with Indian students is what I want to talk about. Indian students, not just Indian students, also the industry practitioners in India, right, have come to appreciate these best practices. So one is so some of the specific best practices is what I will quickly touch upon. Get from day one is something which is quite important. Right? So in majority of the cases, one of the biggest gaps which the industry perceives when the student graduates is that the student has never worked collaboratively with the team in terms of coding and application. Vijay rightly pointed out that the student learns database management separately, front end separately, back end languages separately, but then he is never putting it together. That is one. And rarely in the real world, one application is developed by one person. Right? There are hundreds and thousands of people who collaborate to work on an application like Facebook or Amazon for that matter. And it is important that the student kind of understands, right, certain practical tools which can be useful for him, right, and the concepts behind these tools. Right? For example, there are many Git tools, right, in the cloud, right? So GitHub or Bitbucket and so many other things. But the concept of Git, the concept of version control, the concept of collaborating, the concept of continuous integration is something which the student has to understand from day one, and that is something which we have, right, embraced and we adopted, right. So we even launched a ProGrad junior program where we teach school kids, but even for them, right, this Git is something which we ensure that they adopt so that they see the benefits of using Git, right, and it becomes a habit. Yeah. The second thing which I would like to touch upon is what we call as pair programming. Again, it is one of the best practices where it actually builds both strategy and tactics, right, when it comes to how a student views coding. Right? So pair programming is where two students are paired with each other. One person acts as a driver and the second person acts as a navigator. So the navigator gives instructions to the driver, and the driver actually codes. So there are many benefits of pair programming. And recently we had an interaction with ThoughtWorks, right, where we were actually participating in their think tank, right, in terms of designing their employee development programs. And pair programming is something which was taken very seriously. And ThoughtWorks, for example, is a company which implements pair programming very seriously. Right? So because it not only makes the student code fast, but it also gives him some big picture thinking. He sits back, he kind of looks at the code critically. He looks at how to improve the efficiency of the code when he acts as a navigator. So two students keep taking turns to be the driver and navigator. And in real world, that is how it works. Right? When a person codes, he keeps switching between how to code and then actual coding. So that it kind of simulates it, right? And it's also fun, right? When it is done the right way. The third thing which I want to talk about is test-driven development, right? So that is something which I believe is already being introduced in the academia now, where students are exposed to hidden test cases and boundary cases and all that stuff. But usually, right, development and testing are considered in silos, right? Whereas the concept which is catching up or which is valued in the industry today is test-driven development, where the developer himself tests the code as he develops stuff, right? So that is something which we adopt again starting day one. The fourth thing is around how do we ensure that there is a community learning which is built, right? So one thing which we have to realize is computer science is quite vast, and it's also moving very fast. So it is important for us to kind of bring in the power of many, where we bring in the peer learning for students as well. And as teachers, right, I sincerely believe that I have been teaching this for quite some time, and I sincerely believe that we need to facilitate peer learning, right, as much as we facilitate the instructor-led learning. So we can use tools like GitHub. Like I said, pair programming is one way of peer learning, and GitHub is where the people can collaborate on projects. And we can also use these work communication tools like Slack, right, which are probably used in the companies as well for employees to communicate with each other, which brings in that sort of a coding culture, right? And we believe that is quite important. Code along sessions with the faculty member, right? So the teacher has to code along with the student, right, on achieving a purpose. And I think that is also quite important, right? So when we can take a case study, when we can create some context, right, when we can create a business problem, and then together when the faculty member codes along with the student actually learns a lot of things through induction. So if we keep teaching theory for a very long time, the student is not going to connect the theory to the practical aspects which we will be implementing later. So we believe that every single hour spent with the student, it should have all aspects, right? The skill aspect of it, the knowledge aspect of it, as well as the experience aspect of it. So these three paradigms should be combined to design each and every single lecture hour, right? Is what we believe in when it comes to the best practices. And so majority of the best practices are primarily from the industry perspective, and because we being an informal education player, we have been able to adopt these things very quickly, but we have to figure out how to adopt these things from an academia perspective. So focus on skill and problem solving is something which is fairly straightforward, and staying in the know of trends is also something which is fairly straightforward. So I will quickly talk about I'll take 2-3 more minutes to actually show you some of these things, right? So when we talk about test driven development, what do we exactly do, and how do we ensure that test driven development is implemented? So what is this live coding? So these are things which I can show you one or two of these things, right? So we have design labs and projects, right, which are very close to real life applications, right? And we have these real time code alongs which we have also. I'll show some of these things, and I can also quickly show what a student can achieve with just this is the experiment which we have been doing for quite some time, right? So which is we challenge ourselves on somebody who does not know anything about coding, right? So we will take that person, and then we'll spend 2 weeks, and how much can we achieve is something which is the challenge which internally we run, and we have been trying to push the limits with that, right? I can show you some of the projects which our students have achieved with just 2 weeks of exposure, because we follow majority of these best practices. I'll just quickly go on and then show one of the things.
I'm sorry, Venkat seems to have had a technical issue. So, while Venkat is rejoining us, Hemanth, would you like to share some of your insights on some of the best practices and new perspectives that you have encountered?
Yeah, sure, Vijay. So I'd like to touch upon two things. One, when it comes to computer science education, especially with regard to how we teach programming, what is something that we can, what is the most important thing that we should change? The introductory programming language, the first programming language that a student learns, that is going to be super critical in terms of keeping him interested.
Can you hear me now?
Yeah. So Venkat, you were offline for some time, so Hemanth was just sharing a couple of insights.
Got it. Yeah, should I
Hemanth, if you could, Hemanth was in the middle of something. If you can conclude, and then you can probably resume.
Sure.
Venkat, I was mentioning about the first introductory programming language that the student should learn. So if you see in the Anna University syllabus also, they have changed where earlier when we used to start with C programming, but then now they have started with Python. Especially why this change is happening is uh, the way, as Venkat put it, right, where the student is not able to quickly connect with what is doing with all these programs and how it is going to play a role in building all of these applications or the front end application, the apps, and whatever. So in that sense, if you see, there are a lot of experiments that are being conducted around the world, especially in the Western countries, and they have a super critical problem because all their students are, they voluntarily join their course. So if the first introductory programming language, if they think that it is not going to suit them, then they immediately drop off. So that is going to put a lot of pressure in them to understand what the student wants, how should we teach this. So in that sense, what I would recommend is the first programming language that should be taught, as far as having seen both the academy as well as industry, the students should start with JavaScript, because till 12th standard, everyone would have been exposed to using browser. And when we are going to teach JavaScript, what I'm saying is the minimal HTML that is needed, and we can start with all the existing programming primitives, like starting from if for and all. But then the student will be able to immediately see the result, right? Wherein he can have two boxes, and this is one example I often quote. So we should keep him engaged. So one such the first program that he can, like, for example, he can build a program for flames, wherein given two names it computes so what is the score and which letter matches and so on. Rather than a console based program, if he is going to start with JavaScript, right, that is going to be more appealing. That is going to definitely motivate the students and increase the learning appetite as well. That is one. And two, I want to touch upon how we teach programming as such. So uh, uh, one of the important things that I want to stress upon is computer science education, or for a matter of fact any education, is not common sense. So this education, or how we educate, is also should be engineered in a proper way. For example, one of the outcomes in the computer science education recently is they call it live coding. So what we mean by live coding is, so far what we used to do is we say this is the question and this is the entire program which is the answer for that question. Right? That's how we traditionally teach. So rather than doing that, what we should do is we should introduce the question to the student, and we should code. We should start connecting our laptop or the machine to the projector and start coding, line by line. That way what happens is the student, he gets how we incrementally code, like where do we start, what is the first thing that a programmer does. For example, if for an introductory programming course student, like even 10 to 15 lines is like so huge. Where does the programmer start is something that is going to be super critical, as well as how he evolves from nothing to that 10 to 15 lines of code is like super critical. So uh, if you can browse, you can search for something called the role of live coding in introductory language. There is a recent publication about what is the impact that it is making for the students in terms of the learning. This is something that I want to touch upon with regard to especially the computer science education. Second thing that I want to mention is uh, something called a peer education. So rather than we start a course, usually the course we start a class, usually the class is for about 40 minutes or 15 minutes. What happens is 0th minute the teacher starts, 50th minute he ends. So rather than doing that, there should be interaction between the teacher and student, and also most importantly between the students. That's what they call it as a peer instruction. So I take a class wherein I do something for 10 minutes, I teach them something, and then interact with them in terms of understanding like how much they have understood. Now there is a tool called Clicker, using which it is kind of in Kanban wherein there is a people poll, something like that, wherein each student will have a device or something wherein he can click one of the four options, let's say A, B, C, D. So the teacher will show some questions relevant to what he taught, and the student, the majority of the students, let's say if they say C, and most often the questions are framed such that C is going to be the wrong answer. So what they do is once they answer C and they get to know that it is not the right answer, then the teacher arranges the students into groups, and students, and the learning happens among the student community itself in terms of smaller groups. So this they call as peer education, and especially one of the important tools that is being used is called a clicker. These are two things that I want to they'll reject. Yeah, Venkat, you can take over.
Sure. Yeah, so like Hemanth rightly pointed out, right? I think JavaScript is a wonderful first language to start with. Sorry. And Python probably comes close second, right, in terms of being easy to use, right? I also, to add to what Hemanth said, JavaScript and Python primarily because they're also loosely typed languages. So when the first language which the student learns, right, is Java, for example, right, there is so much of syntax and there's so much of strictness around how the language is typed. Right? Whereas JavaScript and Python are loosely typed languages, so if he even makes a small error, it is not really going to prevent him from seeing the output or discourage him. Sorry. Yeah, so that is something which I agree with as well. And so coming to I'll just I'll take a minute more to kind of connect to whatever I said about whole game methodology. And so for example, this is one of the labs which we have built. And what happens here is so the student actually sees a full-blown application, right, when he learns even simple for loop and arrays, right, and conditionals and data types. After he learns that, he's given a business case and he's asked to write a few functions which will actually kind of go and impact a full-blown application. For example, in this case, right, we are talking about he having to make these filters work. So these filters do not work, and as soon as the student writes the code here, so he will be able to make the filter work. For example, you can see the that the filters work, right, once he writes the function there. So he is able to see what is the importance of these for loops and conditional statements and data types even on the very first day when he learns programming. And when he is able to see that, okay, hey, this for loop is what is making this filter happen, then he is able to kind of imagine that what all can he do, right, by learning programming properly. And he also kind of falls in love with coding. And the test driven development, for example, we have written all the test cases here, which kind of gives him some satisfaction about as and when he writes functions, he's able to see the red green kind of cycle, which gives him some instant gratification, which is what the millennial or not even the generation Z requires, the Instagram generation. They want some sort of an instant gratification for whatever they do, right? And test-driven development actually is the best practice, and it also gives the instant gratification. And if you can build it on short case studies, which are either things which the student engages with on a day-to-day, like for example football, or some business context is given, right, or some website which he has seen, or some game which he has played. So then the student kind of attaches more importance to or the context in which he is learning whatever things which he is learning, right? And I believe we can also ask Hemanth to talk about how what are the traits in students which will help them outperform, right, once they go to the industry. That will be one of the questions which I would like Hemanth to answer as well. So, but broadly, this is what I wanted to kind of touch upon. The big picture around the whole game methodology, as well as the best practices in terms of using Git starting day one, peer learning, pair programming, and test-driven development. So these things are more like habits rather than the specific technology which is being taught. So and habits can only be inculcated by teachers, right, like us. And I believe the students are only as good as their teachers. So if we can inspire them, right, and form these healthy habits starting day one, then we will also see that we've made students fall in love with coding. Is the programming is the thought process which I have. With that, I will make hand it over to Hemanth, and probably I'll ask a few questions to Hemanth, and he can answer these things. You can also keep posting questions later in the chat, and I can post it to Hemanth as well, so that we can have it a more interactive and meaningful discussion. Over to you, Hemanth. I made you the presenter.
While you start, Hemanth, just one question. What is the name of the clicker tool you mentioned?
Like I think it is. There are various vendors who provide that, but essentially the tool is called the clicker.
Okay.
I think one
it's
of the
like
vendors itself is called
polling
the clicker,
software, right?
Okay.
It's a student polling kind of a clicker.
Yeah, exactly.
Right. Right. Okay. Thank you.
So in the device they will have something. The teacher will have a device, and he will set it to some frequency, and then the students also basically will tune for that frequency, because students use the same device for all the teachers classes, right? So they tune to the teachers frequency, and then they do this coding.
Right. Thank you.
Yeah, Venkat, maybe you can get started with the question.
Yeah, sure. So the first question which I wanted to ask you, and I think we have also been receiving some questions from the attendees, right? So some of the HODs and some of the leaders in teaching computer science are in this session, right? So one of the first questions would be, what should be the key change in the way programming is taught, right? If you have to change one of the major things, you touched upon something around live coding, right? So would you be able to elaborate on that? I think that would be helpful.
Yeah, sure. So I'll give an example of how live coding worked for me in one of the classes. So I was taking a programming class for it was in a big auditorium for around 600 students. Okay, so that was like one of the unique opportunities where we take class for such huge audience, wherein I had a lot of other peers as well to help me. But then now we have to keep 600 students in, we have to keep gain the attention of all these 600 students. How do we do that? Where I myself have faced problems where gaining 60 people, 60 students at attention is difficult. So in that particular class, what I did was like they are already somewhat introduced to the programming primitives, basically the if, for, and all these syntactical ways. So I'll pose them a question, something as simple as binary search, or find whether a given number is palindrome or not, and so on. I'll pose the question. I'll give them 5-10 minutes. Some will be attentive in terms of solving it. Some students will be wayward and all. What happens is after 5-10 minutes, I take over the screen. I start typing I start typing from scratch. Like whatever is the answer for the question, barely it will be like around 20 lines, but I start from scratch. So the students will be like, okay, what will be the next line? There is a curiosity that we develop. Even in presentations, right? Rather than having one presentation with the 4 bullet points straight away thrown at and we explain those 4 points, if let's say I introduce one by one, I introduce the first point, then I talk about it. I introduce the second point, then I talk about it. That is a curiosity that gets developed. Right? That is innate to the human. So similarly, what happens is even in this coding, so when I type the first line, there are, the students are curious about what will be the next line, what will be the next logic, or what will be solved next, right? That is one. Two, I intentionally made mistakes. I intentionally made mistakes so that, some of the students who got it right, they'll be confused. Okay, did I solve it right, or is the teacher solving it wrongly? And finally, what I'll do is I'll tell them, there are 3 mistakes in this program, try to figure it out. So these are all nuances that we can introduce using the live coding. As long as we straight away start showing the programs, this is not going to happen, right? Where we will not be able to build the curiosity, we will not be able to make them understand how incrementally code is being developed. So this technique worked wonders in me, worked wonders in that one particular workshop where I did that. And since I'm sharing screen, I'll just quickly search for that test. Yeah, so this is this is one of the papers from computer science education research. So where they detail about how they perform this for a particular control group, and how they assess its effectiveness. And especially this is going to be super critical when we in the first programming language that is going to be taught, right? Because for the second or third programming language, this may not work as good as or the learning outcomes or the effectiveness may not be as good as using the traditional approach. But this is going to work wonders in the first programming language that is going to be taught. So one other thing that I want to stress upon is, we faculties of computer science educators especially, we should keep, tuned to these outcomes of computer science research community. So that is going to be super critical, because even some of the examples that I quoted where I intentionally make mistakes and do that right, they explain all those nuances actually. So it will be super helpful for the teachers. Yes.
That is actually a wonderful insight, right? Primarily because it is not only effective. So what we have seen from our experience as well is that live coding is also very popular, right? So students really love it, right? And naturally effectiveness is also proven. So I think that is one of the best practices which should change, right? If I have to look at it that way. The next question to you, Hemanth, would be. Uh, how see as faculty members, right, at some level we are also slightly siloed, right, in the sense that it is very difficult to kind of keep getting involved in the development of a real world application as well as teach, right? So how do we ensure that we continuously adopt the best practices in the industry as faculty members?
Um, if you have to ask me this question, what I would do is first the faculty should adopt the best practices in the academic system, right? So the academics continuously evolves, uh, and most importantly, I don't want to answer your questions with with one single answer. I actually want to give you the process of how we can do this. For example, as you asked, like how do we follow the best practices, right? For example, let's say maybe I'll explain what I did for one of the courses that I taught, operating systems for undergraduate students. Let me share screen. Uh, so what I did was, I'm going to take, I know I'm going to take operating systems in the next semester. And I know I hate that Shibla short scope, like not to, not to insult anyone or whoever is using it, but then, it did not feel, I did not feel it appealing to me in terms of, whether it I really understood what is operating system after reading that. So I definitely don't want to do that, especially when I'm going to teach it. So I was looking for what are the other practices or other ways of teaching operating system. Okay. So basically, I'll do so. Basically, I want to teach operating system, and I want to learn from it. Yes, like other universities or top universities in computer science, how they are teaching it. Right? So I was browsing through something like okay, operating system lectures. Uh, let's say from one of the top institutes in India. Right? So then I stumbled upon this Madam Maitli's page where she spoke about something called IXPCS. Okay. So what they do is for operating system, they don't teach the theory. They kind of design along with the lecture. What happens is they take each principle of operating system. How can I implement it based on whatever I have learned so far? Whatever they would have learned is they would have learned about programming. They would have learned about microprocessors. That's how the courses come. So this is one great way of teaching where students will actually be exposed to XV6 is basically a Minix. It is called a minimal Linux. So it has exactly around 10,000 lines of code. Basically a stripped down version of Linux that is bare minimal to run an operating system. So they take this XV6 operating system and teach like how system call works, how isolation is provided, and I even gave a lab experiment. This is not even a lab project. I gave a lab experiment where the students implemented a system called in a real operating system, Linux operating system. So they that really shapes the way student learns a course. So this is the process that we should follow for any course of any course. Basically, like whatever course that I'm going to teach, we should continuously try to adapt from our peers, the top universities, or I would even go ahead and search for, if in a specific field of computer science, which university does better, like based on rankings. There are a lot of other factors that we can look around and try to, adopt these practices. So I still remember, students giving me great feedback about using this experience because they felt accomplished. Like, they wrote code, they modified a real operating system. That level of gratification, that is possible only when we seek to adopt these best practices.
Yeah. So one follow up question to that would be: do you think it is possible with every subject? That is one, right? So in computer science, naturally, right, given that it is so closer, right, where you can implement a lot of these things, right? But it still might not be possible with all the subjects. Right, is one perspective. But how do we handle that? This one. And the next question to you, right, will be: how do we make the students actually think about the outcomes as something which is much more than getting a job. Right? So the engineering education's outcome today is being perceived as getting a job. Right? So at the end of the thing, right? So how do we make them perceive it as much more than that? Right? Is the next question to you.
So the first part is like, can we do this for all the subjects? Definitely not. Like we cannot do this for a database course where we can go ahead and change the way how databases are represented in disk and whatever. But there also we can touch upon, like, we can expose students to the code basis of how it is being implemented, and I wouldn't say we need to change every subject that is being taught the way it is now. What I primarily meant was, if we can expose them to something like a real operating system in case of this OS course, that is something that we should do. So most of the things that we follow for other courses might be is the best thing that we can do at the moment, but we should try to continuously improve, is what I want to stress. That is one. The second part is like, how do we enable students to think beyond placements, beyond getting a job, right? If you that the university or the department, right, if you look at their goals, it is about, you can definitely see in the vision statement where every university or the college says they want to make the students as a better citizen, basically, wherein they can contribute back to the society. That is, let's say, let me touch upon that one thing especially. So how do they contribute back to society? So the problem that I see, or the gap that is there because of which students are not there, is the students, they don't think of problems as opportunities. That is that should be the key change that should happen. For example, we can see all the gossips, all the hate speeches, and all that, even from student community, or just passed out students, right? Why does it happen? Because they don't feel like they are skilled enough to solve problems. I'll take one example, or how we can change this. How do we enable students so that they think of as a problem solver than just look at problems and keep silent? What I would suggest is, if you one of the IITs, I think IIT Delhi, what they do is, their final year project or projects that goes beyond 1 or 2 months, right? What they do is they try to solve one of their university problems. For example, they want attendance automation or something like that. Anything that can be solved within the campus, whatever problem they have, they try to solve that. They don't do anything beyond that, and they say that they have enough problems to solve for the upcoming years. So one example that I can see is, let's say I mentioned about Clicker, wherein students can use that, the faculties and the students can use that as a tool to get a poll for a question, right? One such hardware device is not possible for every university to spend or invest, and it is not possible for all the students to buy also. So that is a problem. What we the teaching committee should do is, we should think about solving it, right? Every student has a mobile phone now. We should think of why can't we give a final year project wherein a set of students will develop the server for it, and a set of students will develop the the clients for it. Basically, the app to be used by the students will be done by one set of community, and the app to be used by the teacher can be developed by another set of community. So when we start giving these kind of real problems that exist within the campus community itself, that's when we foster the culture of where the students think of as someone they problem solvers by adapting the technology that they have learned, and that is the mindset change that should happen, if you ask me. And that eventually, wherever they go, even when they are out in the society, they don't think of as everything as a problem. They think of as they think about the second part. How do we solve that by leveraging the technology?
That's a wonderful insight.
A quick time check. So we have about 8 minutes. If we can also open the forum for Q&A from the audiences.
Right. Yeah. So I would request the audience to type any questions you might have right in the questions tab, and maybe meanwhile Hemanth can answer one of the sensitive questions, which is Is there a way for everybody to benefit out of real world problem solving, like you spoke about, right? For example, one truth, right, today, right? So which is a hard truth is that teachers get paid very less, right? So I'm sure, right, you have seen both sides of the table, right? You've been in Amazon, and then you worked as a professor, and then again you went back to Amazon, right? I'm sure you have your own reasons for doing that, but the hard truth is teachers get paid less, right? So can these two be combined, right? Where is there a way in which we can build a thriving ecosystem with teachers, students who are interested, and the industry, right? Solve problems, and everybody wins, and there is some monetary incentives made by the teacher as well, right? So what would you suggest, right? What would be your perspectives on that? Meanwhile, I would request the audience to type any questions which you might have, right, which you would want to specifically address to Hemanth or myself.
Yeah. Venkat, actually, thanks for asking the question. Right, that is the hard truth that is out there. Nobody speaks about it in the in the open forum, but that is the hard truth. Uh, See, engineering education, if we compare it to the universities which pays better, for example, some of the universities that pays better, they actually it is basically we collect fees from students, and that is how the teachers are paid. Like, right. So one of the hard truths is, if we certain universities has policies wherein they cannot collect beyond a certain limit and all that, and we have to accept the fact that the employer cannot pay beyond that, because it is basically the equation where whatever he gets he can pay only as much as that, right? But then is it enough for all the faculties? As far as I have noticed, in the first few years, or at least first 10 to 15 years, right, it's not going to be not going to will all the earning members of faculty, right, can they can they meet the minimum basic standard of living that they want? No, definitely not. So how do we enable teachers to overcome this by preserving all the ethical values as well, right, rather than becoming a second doing second employment and all. So what I would suggest is, uh, when I was a teacher, I did consulting for one of the companies, one of the Indian companies that was involved in doing something called a smart T-shirt. Right? How I got that opportunity is, when I was in college, I was into everything. Like, whichever there are students from other departments who approaches me for solving something relevant to software. There was one such opportunity where I helped them in something small, and there was a connect, because of that student. I got introduced to this problem that one of the industries faced, and I actually ended up having a consulting project with them, and you won't believe, like, once I solved one such project, I started getting more, but I couldn't take it, right? So what teachers should do is, you give yourself for everything that comes at you, right? There will definitely be a network, or there will definitely be a connection that where you will get consultancy work, and you should also try to reach out to, I would say, mostly the Indian industries, right? Uh, Wherein they cannot afford more to solve the technical problems, and if you can solve them for something that works for them in terms of economically, that's going to be super win, right? You get a monetary benefit, and then you can, since that is going to be a consultancy work, there will usually the teachers and the colleges, right, there is a share, you earn some money for your college, and the industry is also going to be super happy, and most importantly, you are now going to expose your students, your final year students, or student projects, you can expose them to these kind of problems, right? So it's going to be super, it will be one of the exciting things that can happen in, especially in academics, especially in Indian scenarios, where the teacher, the industry, the employer, as well as the students, all four people involved wins.
Yeah. So some of the questions from the audience, right? So one major question which seems to be repeating is, what about non-computer science students, right? So they have a lot of there's a lot of fear towards learning programming, right? So how do we conquer that, right? Is one of the questions, right, which is repeating, right? What are your views on that?
Okay. Actually, I am from a non-computer science background, if you ask me. So how did I solve that? If you can, what captured me was there was when the teacher was teaching me one of the algorithms, I got a sense of why can't we apply that and solve one such bigger problem within the college itself. Okay. So how do we enable the non-super non-computer science background to to put effort and don't think of it as a ghost, like now programming is like kind of ghost for most of the students. Uh, don't straight away indulge them in in programming activities. When you give them computers, they are going to be super fake, right? First few lectures especially, you try to teach them or do most of these live coding principles wherein they are used to browsers and type very simple JavaScript programs and show them and see how these things can be achieved and so on. You incrementally build the confidence in them such that over a period of time, within 1 or 2 weeks, they start doing hands-on. I would say even for non-computer science students, right? One super critical thing is using live coding and also exposing them to the first programming language as JavaScript, because they are used to browsers. If you give them console application, they'll be freaked out, right? Because if we compile it in a terminal and then if you're going to show it, they are definitely going to be freaked out. So these two, I think, will definitely benefit Venkat, because I have experimented that with even with the science streams, not even from engineering. So that's what I would recommend.
Vijay, do we have time for one more question?
We may not actually. So I have actually a question from someone who had to leave slightly early. So I'll probably take that up as the last question. And I'm sure some of the audiences here from the training and placement offices, for them, that might be a slightly more relevant question they might want to ask specifically Hemanth. So the question is this: what does Amazon look for in a software development candidate, fresher? What kind of skills?
Okay, so there is no open secret. Like this is out there in every website, right? So uh, I wouldn't speak on behalf of Amazon, but I would speak on behalf of how my interview actually went. Right? That is how it's going to be for all the candidates. So Amazon basically looks out for someone with problem solving skills. I'll touch upon four things that generally happens in all the interviews, especially uh, for a graduate student, right? There are the four things that Amazon looks for. One is problem solving ability, data structures, and then they look at what they did when they were at college, basically their college projects and all that. And fourth one is they call it as design thinking, right? So I'll touch upon the top two things that happens in most of the interviews, right? Or all the interviews. The other two, since for lack of time, I'll not touch upon. So first two things: the problem-solving ability and data structure. So does Amazon look for someone who can solve red-black trees, someone who can solve dynamic programming? Definitely not. For a graduate student, what companies, not only Amazon, any top companies, right? Let's say Amazon, Microsoft, and all, they look for candidates who can solve a given problem in most optimal way in very basic data structures, something like arrays, linked list, stack, queues, and binary trees. These are the 5 primitive data structures that any computer science graduate touches upon. Can they solve problems in these 5 in the most optimal way? That is going to be one of the rounds. And the other round is data structures and algorithms. Given a situation, are they able to apply the best data structures to solve that problem? Two is, to me, if you ask me, I would say it is slightly easier compared to one. For one, what they can do is the student should be continuously exposed to these kind of problem solving. Actually, even for me, if someone has to attend interviews, right, you definitely get a mail from HR of the industry and they say that you need to refresh. Otherwise, even if you are super good and if you are currently in industry, you cannot clear it. That's how the interviews are, right? Because they are going to test you in a very short time. Like maximum Amazon takes a day or two. So definitely student has to refresh on all these kind of questions. One such website I would recommend is Geeks for Geeks, where they post a lot of Amazon. If you can search for Amazon SD1 interviews, right? A lot of students give their interview questions and they share their experience. So start utilizing that one specific website for the matter, and look at different set of programs that they have given. Right? But uh, how do we solve those questions? Uh, there are a lot of things, but let me quickly say one thing that helped me. When I get a question, what I do is I do not immediately look for solution. I look at that question, I sit on that question, even if it's going to take me 5 days. This is like almost like 10 years before when I started preparing for Amazon. So I had around 50 questions or so, but then it took me like 6 months to solve those 50 questions. What I did was I'll take a question, I'll sit on it, I'll not give up by directly looking at the answers for them. Sit on that question, try to solve. It might take some questions might have. I I think it has taken me even like 1 or 2 weeks, but still I sit on that question and try to solve. That is one super critical thing that has to happen, because for that one question, the first, if I say 2 weeks, in the first 2 weeks you will come up with a lot of answers, but all of them is kind of unlearning. You would have approached some incorrect way of solving it. So you need to get throw away all those incorrect approaches from your mind in terms of approaching these problems. So that to me worked a lot. Uh, Especially when I was preparing for top company interviews. So that is
Right.
something that I have seen very, least practiced from the student community, especially these days.
Right. I hope that answers some of the prep efforts that some of the training and placement officers and HODs of CSE and IT departments, etc., might be putting in towards coaching their students for what appears to be the start of the placement season for the 2021 batch. And I'm very sorry that we're not able to take any more questions. We've already shot the time by 5 minutes, but we'll try to answer some of these questions via email to you. We have your email ID. We'll try to respond to some of your questions by email. And because we seem to have just scratched the surface on how exploring the new perspectives on new paradigms on teaching code, I'm sure we would get a part 2 for this session happening soon, and we would send out the invite to all of you. So thank you very much for patiently attending this session beyond the 4 p.m. Time, and thank you for the panelists Venkat and Hemanth for taking the time out to address our audience. Thank you very much.
Thanks, Vijay. Thanks, Vijay. I actually wanted to say one thing. So, uh,
Sure.
uh, sorry, faculty, that we were not able to answer all your questions, but I'll definitely get in touch with Vijay and Venkat and try to get back to you with answers for those questions. I'm actually interested in trying looking at all those questions, and I'll definitely help them get back to you with answers. Thank you so much.
Great. Thank you. Thank you, Hemanth. Thank you,
Thank
everyone.
you so much, everybody. Thank you, Vijay.
Same.